Hi, hallo, grüezi. So as you can see, we're in my lab at work. As some of you know, I work for the University of Basel, the Department of Biomedical Engineering, where I had the 3D printing core facility. So because of that, we actually now have a 3D printing symposium going on end of this week. And I was asked if I could prepare the prizes. Like, we have this little pitch award where the PhD can show off their research, and whoever pitches best walks away with some prizes. In this case, they get an X1 carbon Bamboo Lab printer. Second prize gets an A1 mini, and third prize gets filament for 3D printing. And they asked me if I could provide them with some awards to give them, because the prizes will be sent home. So I really like to design awards, and I did many of them in my lifetime. And I always go a little, let's say, out of my way to make them cool. So I want to take you along for that journey. So that's basically what I came up with now. So the 3D printing symposium is about 3D printing in life science. And because of life science, of course, a DNA spiral comes into mind. But I wanted to bring the part of 3D printing and improving 3D printing in life science into it. So what I actually did here on the bottom, you can see, let me quickly bring that a little bit more visible. As you can see, like down here, you have like a lot of blocks, actually kind of voxels, you could say. And then up here you have like a really bad resolution string for STL. And up here you have 3D printing layers, basically, that are stacked on top of each other, but they get finer and finer the more you get on top. And then you have the spiral, very clean. On top you have a little like acrylic glass plate with engraved, in that case it will be Best Pitch 2024, and a little gold coin or silver coin, bronze coin, whatever, for first, second and third place. And down here, of course, our logo 3DP Basel. The idea is actually to 3D print most of it, but I want this to be hollow and I want it to light up, because I really like to incorporate light into my award design. It's always a wow factor if you switch it on. So the logo I will print in multicolor polyjet, that it's kind of see-through, kind of color. But the actual award itself will be done with selective laser sintering. And the top I will laser cut, and the coin itself will be milled. So for the actual light up part, because the award will be about yay big, I got those. These are LED like strings, basically. So you ever saw those old looking kind of light bulbs where you have the glowing filament inside, and it looks like it is the old glowing filament, but it's still an LED lamp? That's basically what they are comprised of. And I'm really looking forward to working with those, because I wanted to try this a long time, because they don't have individual LEDs visible if you switch them on. They're super flexible, so I wanted to try them out for long. They run off 3 volts, but they take about 1 amp of battery power. So a battery like that will last you for about 1.5 hours maybe, but that's plenty for an award. So as you can see, I can just hold them on there and they light up beautifully. And they're actually freaking bright for like 3 volts. I tested them with my power supply, so you can overvolt them to about like 3.7, 3.8, even 4 volts sometimes, but I measured like an amp intake. So these little CR123A batteries will last you 1.5 hours. But yeah, like I said, that's good for me. So that is actually what I want to put into my award. So as of now, I don't have 3D printing capabilities in laser sintering in-house, unfortunately. As of now, I can't print, but I told you, end of week I have to give the awards out. So that's where our friends from PCBWay come in. So PCBWay was kind enough to sponsor this video, and I simply uploaded my design. I removed everything that is not laser sintered. send it to them, but I also gave them the metal coin to do, because they offer CNC milling as well. And let's see what they sent. Don't cut yourself on camera. So, as always, very well packaged. So that must be the awards, and these must be the coins. So let's see. Let's unpack the coins first. I'm really looking forward to those. Because like laser sinter parts, I saw millions in my lifetime. That's actually, laser sinter is my sole specialty in 3D printing. Not sole specialty, but my biggest specialty, I would say. But at my heart, of course, I am a metal worker. So let's see how good they are. Ah, that's the copper coin, it looks like. Ooh, nice. Oh no. I think I f***ed up. Third is silver, second is copper. God damn it. Did I f*** up or did they f*** up? So it's milled to perfection, but I f***ed up. The engraving with second prize is the copper one, and the silver one is third. Not good at all, but we have to roll with it. End of week, I don't have time to redo anything or whatever. So we can explain like, okay, we have gold, obviously the most valuable metal, and then copper is more expensive than aluminum. Yeah, shit. But yeah, we have no time for like redoing anything. So let's look on the SLS parts. Let's hope I didn't f*** up anything there. But hey, that's life. That's basically, normally I would reorder and everything and you guys would never see that I messed up, but this time we are under time pressure. So you see behind the scenes how many attempts it sometimes takes. And sometimes it's human error. Sometimes I am the human error. Fuck no.
Hello, darkness, my old friend.
So, I messed up. Big time. I ordered everything wrong and I can't fix it anymore. Like, I have 3 days left. So, we have to come up with something. I wanted to have it in SLS, but now I got those, as you see. They're missing parts and they're not hollow at all. I sent the wrong data to print because I named it wrong. So now we have to salvage. I actually have one good laser sinter one, and this one will be the prize number 1, like first place. And the others I will test now real quick. I can print them in FDM and if they will still work. Because like at the end it's just white plastic basically. It's just about the see-through part basically. That has to be figured out. And then of course the wrong coins, we will just roll with it, I would say. So we will have one that is as anticipated. So basically I already finished that one. So this one will be the good and the nice one. And the other ones will be a little shabby. So what I actually do right now is I will print a little bit of the data here, just to see if this puts light through that, if it is PLA. So let's quickly try that. So I have PLA basic loaded, slicing. It's about 25 minutes. Let's print that. It is on the second printer. I cleaned that one out. So let's send. Let's quickly test that. I will actually put the machine on high-speed mode to get it done even quicker. And then we put our strings in and test. Let's see. Okay, it doesn't look that bad, to be quite honest. So let's see if it lets light through. So we simply thread that through. If it lets light through, we are saved. So I threaded it through. I will simply just use my little batteries for it to see and hope. You know what? It's actually a better diffuser than the SLS. It will, fuck hell, it will even look better now. Oh, okay, we messed up, but we saved it. So, but that means that I actually will put this one online for you guys to print. So you can do one yourself for whatever. I give you full permission to give it out as a prize. It's my own design. So, 2 fuck-ups later, I would say let's quickly get the little acrylic sheets done. I have a laser cutter myself, so luckily these I can make myself. So let's quickly engrave them downstairs. So, while this all is printing, I want to talk to you a little bit about problem solving more specifically, because I think one of my biggest strengths as a tinkerer, but also in my work, is that I genuinely don't see problems as problems. Like, there is always a solution somewhere. So it's very easy for me to be like, hell, it didn't work, I have to reprint it, or I have to cancel the prizes, or think about something else, because I already shot myself into the idea of exactly this product. It is very easy to basically get lost into that and simply like give up. When I encounter a problem in my everyday work or in tinkering, I always have immediately 3 to 4 different solutions by simply giving up on little details that are not that important. Like, you see, I wanted to have it laser sinter printed. I fucked up. I uploaded the wrong data to the supplier and didn't double check. Always double check. I simply switched over to a different technology, and you know what? If I give the prize out to the recipients, they don't know that I planned it in SLS. Always see problems or setbacks in your process as kind of a challenge to yourself, or as kind of an opportunity to do something even better. So that being said, let's check on the new print. Somehow, with all the support structure, it looks even cooler. I would love to leave it like that, but no. Of course, we will remove the support. And I think like the quality of this printer is like astounding to me all the time. It actually looks as good as the SLS print. So let's quickly remove those supports. With this printer, no effort whatsoever. Like, I know I do a face like I have super effort to break it apart, but I'm actually just concerned about breaking something. But it's actually super sturdy. We have some like, oh no, yeah, some little bad surface down here, but that's actually the area where I wanted to have a lot of like layers. As you can see here, I designed the layers, and here they're hanging a little more. So that's good. I want to see the improvement of 3D printing upward, and it looks, well, good enough, I would say. So the thing is that I want actually to use batteries in that, and they deliver like constant 3 volts, and I need 3 volts for my electricity or for my lights here. And so while these were still printing, which took about 1.5 hours, not bad for that size, I've gone ahead and designed this one. This is basically a battery holder where I will use some like metal plate, I have it somewhere, and do little springs here that actually then I can put my wiring on. So let's see if our battery compartment fits in there. Oh, snug. Oh, that's fucking awesome, is that? I will actually prepare my battery cases before we go to soldering, because then I can simply like put everything together already and solder it. So for these battery cases, they have like little slits here in the side, and it fits the battery pretty snugly, I would say, like with a little bit of wiggle room. And what we're doing now is like I take this aluminum sheet and I cut little strips and pre-bend them, so they actually give me kind of like a little string. Let's see if we can fit it in here. Yes, it has like a little latch. So I'm putting this on the latch. I'm bending it outwards, so we have like a little bow, I would say. And the latch will basically keep it where it should be, and then I simply bend it into the latch I cut it off to the length I need it. So it bows it out a little bit, and you see there's like a little aluminum spring now. And if I try to compress it, the latch will keep it from like simply flipping out, and on the top I will glue it shut. So the thing about aluminum is it's basically impossible to solder. So what I will do, I will drill like a little 2mm hole in it, and then I will put the wire through it and knot it onto it, and then solder wire to just keep the tension. And then I can put them in here. So I want to prepare all of these little latches with all the holes drilled and everything, so I can then solder everything shut, put it together, put the batteries in, and it already lights up. Okay, let's go over to the vise and quickly drill everything, and then we can proceed. Follow me, I guess. We're at the soldering station now, and I will quickly show you how to find out polarity of those. So the thing is, of course, you can bring your battery and you simply like try to touch it, nothing happens, and you turn it around, it lights up, and you know this side is plus, right? But the thing is that the plus actually, you have this little hole in one side of the tabs and the other one doesn't have it. So the whole one is plus. So you can basically go after that. So I know I want my plus side, just so it's easy, up. So I will always see that my hole is on the upside. So what I will do first, I will actually solder a little bit of wire, because it will end up here, but we have to connect plus, of course. So what I will do, I will take a 0.14 square millimeter wire, because that's enough for 1 amp on like 20 centimeter of way what we have here. So that should be absolutely fine. And just in case, I asked ChatGPT again and it said it's fine. So let's trust the AI. Okay, so we have our lasered plates. So I will quickly install the coin for it. So here we simply do some dabs of super glue to where the coin should go. We put in our copper coin in this case for third place. Press it shut. While this is drying, I will actually show you how I printed those. That's our logo. It's the 3D Basel logo. So while I prepare the 3D printing data, I explain you a little bit about PolyJet 3D printing. So PolyJet uses a liquid polymer that is squirted out of the printing head that has like hundreds of microscopic holes in it. And it squirts this on a printing bed. Then a roller flattens the surface so it's nice and smooth, and a UV light hardens it right after. With that, you can print multi-material and even clear materials in this machine. Those are the printing heads I was talking about. It has 3 of them, so we give them a quick clean so the liquid can squirt out better. This is the roller that flattens the surface of the part. It's quite important to be super clean. And this is the UV light that hardens the resin. So we can install this guy right up front. As you can see, I already did with those 2. Basically in front here. So I want this and this to show into the right direction, into the same direction, I mean. Okay, the glue here didn't. Oh yeah, I forgot to put hardener on, sorry. So I want all of it to face in the same direction. So I will actually like put that in just for comparison while it's drying. And I know that this one should go right here. So all we need to do is like 2 little dabs of super glue, like 1 in the corner, 1 on the back. The less the better with super glue, always. And then we put it right like that. Like, funny story, super glue in Germany is actually called Sekundenkleber, which means second glue, because it's supposed to glue parts together within a second, but it never does. I would call it minute glues and sometimes never glue. You get what I mean. So this should hold after drying a little bit more. So how is our coin doing? Our coin is doing fine. So we actually add a little dab of glue like down here and onto the little ledges. You really don't need that much, because on plexiglass, super glue actually is super for once, and glue is like awesome. And you don't want to touch the glue with your plexiglass on any other position than you want to glue, because if it touches, it messes up the plexi because it basically eats into it. So we just hold it till it's dry, and never use your spray, because if you use it, it will react with the plexi and it will completely fuck up your plexiglass. PMMA, plexiglass, however, I think plexiglass is actually a brand. So now that this is done, we simply have to put in the batteries, and we have first, second, third place. I was thinking about actually doing another video about this award, or about awards in general, where I explain how you actually design award from the ground up, from the idea, conceptualization, everything. So let me know in the comments down below if you want to see that, and other than that, watch one of my other videos or simply enjoy the cinematics. See you later.